Hello friends, in this video I am discussing differential calculus. This is the one of the important topic uh, in many university exams like Bangalore University, Central University, Bangalore Northern University, and not only this university, other universities also. This is the one of the important topic, and not only university exams, and this is the very important topic in many competitive exams like IIT GATE, IIT Jam, and CSR NET, and many MSc entrances, BHU, DU, and Central University exams, and many other competitive exams also. In this calculus part, these are the subtopics and very important topics in this calculus. First one is limit of a function and continuity and discontinuity of a function, differentiability and mean value theorem and Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem, Taylor's theorem, Maclaurin's series, evolution of limits by L'Hospital rule, and indeterminate form 0 by 0, infinity by infinity, 0 and 0 into infinity, 0 infinity minus infinity, 0 4 of 0, and infinity 4 of 0, 1 4 of infinity. These are the subtopics comes from calculus, very important topics. We see the limit of a function. Limit of a function definition is let f of x be defined in deleted neighborhood of a belongs to R, then L belongs to real number R is said to be limit of f of x as x approaches a if for given epsilon greater than 0 there exists delta greater than 0 such that mod of f of x minus a less than epsilon whenever mod of x minus a less than delta. Therefore, limit extends to a f of x is equal to L. This is the one of the definition, and the other definition for limit of a function is a function f of x is said to tends to a limit as x tends to a if both the left and right hand limits exist and are equal and their common value is called the limit of the function. That is left hand limit when x less than a and x approaches to a, that is x tends to a, limit x tends to a minus f of x is equal to limit h tends to 0 f of a minus h, and right hand limit is when x greater than a and x approaches to a, limit x tends to a plus f of x is equal to limit h tends to 0 f of a plus h. A limit exists if and only if left hand limit equal to right hand limit. Here a is um, limit at a point. A means limit at a point. We see this some few examples related to and few examples and few questions related to limit of a function. Question number 1 is limit extends to 0 mod of x by x. Now we have to find the limit of this function. Solution for this question is we consider the definitions for left hand limit and right hand limit. Left hand limit is equal to limit x tends to 0 minus mod x by x. We are applying limit of left hand limit definition, limit x tends to 0 mod of 0 in place of x we replacing 0 minus h. In place of x we replacing 0 minus h by 0 minus h, and h tends to 0 we get the limit as minus 1, and right hand limit is equal to limit x tends to 0 plus mod x by x equal to limit h tends to 0. In place of x we replacing 0 plus h. 0 plus h by 0 plus h mod of 0 plus h by 0 plus h, we get limit as 1. Now we see that limits are not in a queue, therefore limit left hand limit not equal to right hand limit, therefore limit does not exist. And we see the second example, show that limit extends to 0, x sin 1 by x equal to 0. Left hand limit is limit extends to 0 minus x sin 1 by x, limit extends to 0. In place of x we replacing 0 minus h, we get we get 0 minus h and sin of 1 by 0 minus h, limit extends to 0. We know that sin of minus theta is minus sin theta, and minus and minus multiplied to give positive, therefore limit extends to 0, h into sin 1 by h, we applying limit, we get 0 into, and sin value is always finite, 0 into a finite quantity between minus 1 and 1 gives the again 0 only. And left hand limit is equal to limit extends to 0 plus x sin 1 by x is equal to limit extends to 0, 0 plus h sin 1 by 0 plus h, limit extends to 0, h sin 1 by h, and we are applying limit, we get 0 into a finite quantity between minus 1 and 1, we again get 0 only. Therefore left hand limit equal to right hand limit, therefore limit extends to 0, x sin 1 by x equal to 0, limit exists. Prove that limit extends to 0, 1 by 1 minus e power of 1 by x does not exist. We have to find left hand and right hand limits. Left hand limit is limit extends to 0 minus f of x equal to limit extends to 0 minus 1 by 1 minus e power of 1 by x, limit extends to 0. In place of x be replacing 0 minus h, 1 by 1 minus e power of 1 by 0 minus h, limit extends to 0, 1 by 1 minus e power of minus 1 by h, we applying limit, we get e power of minus 1, limit extends to 0, e power of minus 1 by h equal to e power of 1 by 0 is infinity, e power of minus infinity value is 0, 1 by 1 in place of e power of minus 1 by h, we replacing 0, we get 1, and left hand limit is limit extends to 0 plus f of x equal to limit extends to 0 plus 1 by 1 minus e power of 1 by x, in place of then limit extends to 0, in place of x we replacing 0 plus h, we get 1 by 1 minus e power of 1 by 0 plus h equal to 1 by 1 minus, we applying limit, we get e power of 1 by 0 value is infinity, and e power of infinity value is again infinity, therefore 1 by infinity values gives 0. 1 by this entire term becomes infinite because e power of infinity value is infinity, then we adding or multiply subtracting any value with infinity, we get again infinity, therefore 1 by infinity value gives 0. Therefore we see that limits are not equal, that is not in a queue, therefore limit does not exist. And we see the another example, if f of x 2x plus 5 for x less than or equal to 1 and 6 minus x for x greater than 1, find the limit extends to 1 f of x if it exists. Solution, left hand limit extends to 1, limit extends to 1 minus f of x is equal to, in place of f of x we considering 2x plus 5 because x less than 1, x less than 1. That's why we consider 2x plus 5. We in place of x we replacing 1 minus h. We get 2 of 1 minus h plus 3, and we get 5 minus 2h. We applying limit, we get 5. And right hand limit extends to 1 plus f of x is equal to limit extends to 1 plus in place of f of x we replacing x greater than 1 value, that is 6 minus x, and we get 6 minus x in, and limit extends to 0. In place of x we replace 1 plus h, 6 minus 1 plus h, we get limit extends to 0. 5 minus h, we get limit as 5. Therefore left hand limit equal to right hand limit is equal to 5, and limit extends to 1 f of x exists and is equal to 5, because x less than or equal to 1 means x equal to 1 value also 5 only. That's why the limit exists. Thanks for watching.